All right, now we're moving on to the design of the project. You received your software design. You received your software requirement specification, and now you're going to do your design specification, your design work. So it might not always produce a specification, but there's a really good chance that it will. Stillman and Green talk about there being various options to doing your design. And they present it as this. Oh, some teams might just start coding. Basically, the design is on the fly. A better version of this is that they'll go and they're going to prototype the interface for the users. They'll then demo this to people, get feedback, and then they throw this work away. This is just to learn to avoid wasting their efforts. So it's sort of designed by building something lightweight rather than designed by building the whole thing. Or, no, they're going to be making pictures, mock-ups, they've got flow charts about the way things are going to work, etc. And then this is a more detailed, but they're not writing code, so it's at a higher level. They could be planning out and documenting what the actual object models are they're going to be using. What are the objects in the system? What will those objects do? And they could detail this in great detail and design it. They could create their entity relationship diagram. And so, let's do the database specification. All right, we specified what the database is going to be. Now we know what all the models are. Well, and then what are all our routes? What are all our controllers? This will do this and it'll do this. All right, we know what all our objects are, and our objects are going to send the following messages to each other back and forth, calling each other. But yes, we haven't written any code yet. But now that we've planned it all out and we see that it's all going to work out really nicely, we could get to writing it. Likewise, all of this could be put into the design specification. Using all or some of the above. All right. And this is what you're doing as well when it comes to design work, when you need to start working on stuff. Some of you just dive in and start coding. Others of you, let's be sure that we make some new mock-ups of the way things are going to look before we start doing it. Rather than just try to make some tables, I want to figure out how they all fit into the database. And let's talk about the models that we're going to have. What other classes might we need? Let's talk about that. Let's as a team, let's plan out, I already just said all that, all those routes and stuff. But so you guys are doing mixes of this. Each team needs to decide what is appropriate, just as a team in the waterfall world would decide what's appropriate. With a design specification in hand, then you implement it. Okay, so your specification says how you plan to implement it, but then you actually have to implement it. And so that's when we get into our actual coding and or the programming, whatever you want to call it. And with that, this is where we've got good engineering practices with version control, with unit testing, and we have all of our reviews of stuff. So we've got to have good engineering practices on how we're actually going to be doing that work. All right, once you think you've got all the code built, usually the classic notion is then we begin testing in the waterfall. Okay, we're talking about here is focused on user acceptance. Will this thing do and meet the expectations of what the client wants? Often in the classic approach, you have a QA team. And the QA team actually starts working on this based on the software requirements specification. They don't wait for the coding to get done. Everything would be massively delayed. So they start creating, they take the software requirements design specification, and they start writing their test cases. Okay. Oh, you should be able to go here, type in this, and see this. Oh, when they do this, they'll get this error message. And they're writing all of these tests out. This is largely traditionally manual testing. But today, of course, it could be that they're busy writing automated tests for all of this stuff. And that if you have implemented your stuff right, according to the requirements in the design work, we should be able to test it. Okay, so based upon the design spec, so this is the software requirements and the design spec. So based upon that, they should be able to write the tests. And if you implemented it right, you'll pass the tests of the QA team. This really gets going, really starts testing. Once you can be making all the tests, but to really do the real testing when we reach this stage called code complete. So this is when the development team declares, we have written all the code that we believe that we need to write to implement everything. That's not, we declare all of our code to be high quality and working correctly. Traditionally it's, we've written it. This whole notion of code complete really should just be jettisoned. As I've already talked about, really the modern correct engineering approach is, we're not going to let that code be in the main branch of our repository until we really believe it is good and functioning and correct and proper. You shouldn't, code complete is kind of the state where you are when you're like, yeah, I think I'm going to write a commit message and commit it so that in case I don't lose it or something. Oh, I still need to improve it. Oh, I wrote more tests. Oh, I refactored it and a whole bunch more commits and so forth and so on. Yeah, code complete is kind of like you wrote it and you think it kind of works. This sort of, delaying this, imagine months and months and months of work. And then you finally start checking to see if there's bugs. It's no wonder that we run into disasters with that approach. So there's, again, if I was to take the waterfall approach and sort of modernize it, well, of course, what we're going to do is we're going to squeeze together that programming and testing. We're going to put our code reviews and have a better engineering practice. So it's not necessarily, it's if we stick to the notion where we hand things off to teams and we break things up in this fashion, yes, we're going to still have a lot of the same problems. If we let our developers code without, got some unit testing, but if we let them really code without proper testing, without proper reviews, we've got problems. So these are critical that they would be there. But too often, I'm sounding like a broken record. It's too often, yeah, oh, waterfall doesn't work. Well, it doesn't work because our engineering practices at the time weren't sufficient. I have a neighbor on my street. He works in Waterloo and they do tons of software and they fully use a waterfall approach and the company is very successful. I believe that's probably because they have modern engineering practices being applied to that development process. What seems to be working better for people in general are the agile approaches. And that's why we're teaching them to you. And the agile approaches also fit, I believe, this design cycle in school, it works better as well. Anyways, so you get this, so when you're doing this testing, a really big part of this is you need to note all the bugs. So the bugs are listed and put into a system. You have to have some sort of system to do defect tracking, defect tracking, and you're going to, this is always, you're going to describe how to reproduce it, because, you often have someone else find the bug, and so they have to write down what it is that you did wrong. Very commonly, you'll record a priority for the bug, as well as describe the severity of the bug. These are different things. You could have a really high priority bug that its severity is only cosmetic. It's just so embarrassing to have it that you better fix it. But it doesn't cause any loss of data or anything like that. So a severe bug is something that causes, usually loss of data or other serious issues. You'll then usually, so you're spending all your time, so dev work is about fixing bugs. So now after your code complete, you're spending all your time bug fixing as people are finding bugs, putting them in. So your day is spent going to the defect thing, pulling up like the next highest priority bug and saying, yeah, I'll work on that. You work on it, you submit a fix, and then someone checks and verifies, did you really fix the bug? There is this also a really big notion of triage. So as now you've written all this code, now you've found tons and tons and tons of bugs, and it's taking forever to get the bugs fixed. And as you fix bugs, you introduce more bugs, and it seems like it's never going to end. You might very well enter into triage to say, we've got to say this software is done at this point in time. What are we going to get fixed before that time? And so you start picking some bugs that they're going to get fixed and some that are not going to get fixed. You triage the cases and decide you will get fixed, but you're not. Anyways, we move on from there. Once we think we've got it to an acceptable level of quality, we deliver the software. The classic notion is we ship it. All right, at Microsoft, you get your Ship It Award. I don't know if they have those anymore. Now that they do continuous delivery of software. And then finally, at the end of this whole thing, we run our post-mortem. Again, we spend maybe a day as a team after having worked for months or a year or more, and we talk, what did we learn? How could we improve as a team? What were the mistakes? What are we going to walk away from? So this is a practice that has certainly been adapted and absorbed into Scrum and then amplified. We're not just going to do this at the very end of the project. We're going to do it at the end of every single sprint. We're going to really focus on continuous improvement for our team. It's really important to us. It's not just a tacked on thing at the end of a huge project. It's a continuous thing that we're dealing with on a very frequent basis. All right.